Part number 8 is also a standard IPT. This part we're going to be creating it on the XY plane, and I'm just going to be putting in some lines to give me my general shape. Here is where I'm going to stop. I have 3 lines drawn. I'm going to switch over to an arc. Make sure that you have the 3-point arc selected. Click here, here, and then the radius, and then continue drawing your lines. And you should end up with something that has this general shape. Once you have that, go ahead and start dimensioning this. From top to bottom, this should be 1.062. Our diameter here is 0.25, so we're going to put in 0.125 because it is the radius. Our diameter here is 0.625 divided by 2. Our diameter here is 0.875 divided by 2. Our radius on here is 0.312. This has a height of 0.06 and a angle of 135 or 45 degrees. And then this section here, from here to here, this should be 0.562. Oh, and then our last dimension here is 0.812. Okay, once you have all of this drawn, go ahead and finish your sketch. And we are revolving this around the center axis that we left. And we should end up with something that looks like this. We need to change this to SAE 4320, which happens to be an alloy steel, which means it's just harder than regular mild steel. And it doesn't look much different, but go ahead and save this as number 8, rack pad. Number 12, screw. The screw, we're going to be creating it again using a revolution. So create a few rectangles, one that goes up vertically and one that goes out horizontally. Next, create an arc, a 3-point arc from the bottom of our first rectangle to somewhere right here on some other point, and just kind of make it look like that. Go ahead and click on tangent because we do need to lock this arc to be tangent with this line, and everything should adjust. And now we can go ahead and add some dimensions. Our first dimension is going to be our overall dimension of 0.562. Everything should readjust. This section here should have a width of 0.181. And then this point of our arc to this line of our rectangle should be 0.062. And this should have a diameter, or I'm sorry, a radius of 0.75. Okay. Our last dimension that we need is the thickness of the shaft, which is 0.25 divided by 2. Once you have all of that, go ahead and finish your sketch, revolve, select just this blue section and this green section. Our axis should be this, and I'm going to rotate it so you can see what's happening and say okay. So as you see, we have this curved surface of our screw, and the rest of our screw is seen as such. We need to go ahead and put in a cutout for the screw head, or the screwdriver, the slotted head. So we need to make a new sketch, click on the plus sign of the origin, and scroll down to the XY plane. Next, create a rectangle that cuts into the part, like that. Right click and go down to Slice Graphics. Once you have that, you can see the inside of the part. Click on Horizontal Constraint, find the midpoint of our line and the origin. Once you have that locked, we can go ahead and dimension. This should be 0.062, and if it adjusts like this, don't freak out. Just click and drag it to where it should be. We need to go ahead and project geometry. We're going to project the geometry of our arc and then dimension from this green dot of our arc to our actual line of our slot, and this should read 0.094. Once you have that, finish your sketch, go to extrude, rotate it so you can see what you're doing, and make sure that you select everything. We're going to make this a symmetric extrusion, and we're going to cut all the way through in both directions like so. We need to add some thread, so click here. This should be 1/4 20 UNC, which it is, and say OK. The material for this is SAE 1040, which happens to be another type of steel, but you can just go ahead and select just plain steel, and it'll look something like that, perfectly fine. Click Save, and this is 12 screw. Let's go ahead and start with part number 7. We're going to be creating a revolution on the XY plane, and I'm going to make 2 rectangles, like so. This has an overall width from left to right of 2.437. This here is 0.75. And our diameters are 0.495 divided by 2 and 0.749 divided by 2. Once you have that, go ahead and revolve both rectangles around our center axis like so. And now we can go ahead and create the gear. We're going to be creating right here on this surface. And I want you to go ahead and project the geometry of this center circle. The first thing that we need to do is draw a gear tooth profile. So it should look something like this. And then I'm going to draw a line from the origin to the center, or somewhere out here, and connect it to the center of my gear tooth. I should also connect the bottom of my gear tooth to this line, so that way everything stays symmetrical. Reading the information of a gear is quite difficult because there's a lot of information to take in. This part is especially difficult because it is missing information. So we're going to try our best to create this with the information that we have. The first dimension that we need to add is our overall diameter. In this case, the overall outside diameter is 1.164 divided by 2, and that is the top location of our tooth. The next information that we know is the gear depth, which happens to be the hole depth of 0.183. The next set of information that we need to put in is our pressure angle. The pressure angle is where the two teeth of a gear or gears meet. So the pressure angle normally is from this angled surface to the center of the tooth, but unfortunately for this drawing, it's incorrect, and it should be from angled line to angled line, and this should be 20. The next piece of information that we need to add is from the center of our tooth here to the center of our tooth here, this is the tooth thickness at the pitch line, where the two sets of gears will actually meet. The pitch line, or the tooth thickness at the pitch line, is 0.1309. Once you have that, here is the general shape of what the tooth should look like. Unfortunately, it doesn't touch anything, so we need to go ahead and draw the rest of the tooth down into the actual part. Okay, so if you have this general shape, that's fine. Next, click on collinear to make sure that this line and this line are the same, and this line and this line are the same. As long as this bottom line is inside of this outer circle, that's what I want. So let's go ahead and extrude this tooth. So make sure that you select all of the segments, and we're going to be extruding this by 0.5 and say OK. Now that we have one tooth drawn, we can create a circular pattern. Make sure that you select extrusion 1, and our rotation axis will be this cylinder here. We are patterning it 12 times, and you will end up with something that looks like this. Now, this doesn't look like a gear, but we are going to fix that. So make a sketch on this face of our gear, and we are going to create a circle, finding the center point or the origin and drawing a circle like so. From the top of the tooth to the top of our circle, and make sure that that symbol pops up. It's dimensioning to the edge of our circle. This should be 0.183. Go ahead and say, or click enter, finish sketch, rotate it so we can see what's happening, extrude, make sure that we switch directions. We're not cutting, we're adding it. And here is what this gear should look like. Okay. Now these aren't the correct steps to take when creating a gear, but unfortunately the information from the book is incomplete, so this is as good as we can get. The last few things that we need to add are holes. So we're going to add a hole here. Make sure that it is concentric with this circle, and this should have a diameter of 0.25. It should read 1/4 20 UNC, and the depth of this should only be 0.4. And make sure you change both dimensions here. and say OK. We need to add a hole through the center of this. So we need to create a new sketch on the XY plane. Find the midpoint of this line, move your cursor in, and then click. From that point that we just added to this line, this should read 0.395. Hit enter. Once you have that point, you know exactly where to draw a circle, and this hole should be 0.375. Hit enter, finish your sketch, and extrude this in both directions and make sure that you're cutting it all the way through. So both directions all the way through. The material for this is an alloy steel. So go down to steel alloy, and now we can save this as part number 7, gear. Number 11, rack, is on another standard IPT. Create your first sketch on the XY plane. We are going to be creating a simple rectangle, like so, with the dimensions of 0.625 tall and 4.375 wide. Once you have that, go ahead and extrude by 0.498 and then make a sketch or make a new sketch and then make a sketch on the front face, and we're going to cut out our tooth. Like with the last cutout or creation of a tooth, I'm just going to draw the general shape of what a gear tooth should look like, something like this. And then I'm going to make sure that the center point of this line is in line with the center point of my bottom line. After I know that it is exactly perfect, I can start adding my dimensions. Our angle is going to be 20. The height of my tooth is going to be 0.183, and it will move it, so don't freak out. Oh no! And it will move it, so don't freak out. We just need to dimension it and get it into the right location. So use your constraints. I'm going to use my collinear line to line it up right there with my top line, and then I can keep adding dimensions. I need to draw a line from the center to the center here, and the tooth thickness will be 0.1309. And I need to locate this tooth. I'm going to click on this endpoint, and my line on my left side, this will be 0.75. There we go. This tooth looks correct, so let's go ahead and extrude this. Okay. So instead of drawing 12 teeth, all I'm going to draw is 1 and then pattern it with my rectangular pattern. Choose extrusion 2. Our direction should be this line here. Flip the direction. We are patterning this 12 times with a spacing or linear pitch of 0.262 and hit OK. Once you have that, we need to add chamfers on this corner or on this side. The distance of these chamfers are 0.06. Say OK. Then we need to add a hole over here. Click on hole, click the bottom line, and type in 0.312. Then click the side, either the front or the back, and this should read 0.25. Our hole is a simple hole with a depth of 0.625 and a diameter of 0.25. Say OK, and there you go. This also has the material for this is also 4320, so it is an alloy steel. Save this as number 11, rack. Part number 13 is fairly simple. Start on the XY plane and create two rectangles. Our first dimension that we need to add is our overall height of 6 inches. Our part sticking out has a height of 2, and it is 3.5 inches wide. And this section here is 1 inch. Next, click on Fillet. Change our radius to 1. Click on this corner. Then change the radius to 0.38. Click on this line, and there you go. Next, add a circle with a diameter of 0.5 and a location of 1.062 and a height location of 1. Once you have that, go ahead and extrude by 0.98. Turn it around so that we are looking at this face here. This is our next sketch. So go ahead and click on Project Geometry and choose this rectangle. We're going to offset our rectangle by 0.125 and then put points in each of the corners. Once you have that, finish your sketch, go to Hole. Inventor sees those points and knows that those are center points, and it automatically places holes. This is going to be a tapped hole with a diameter of number 8 or 0.164, and it has a depth of 0.438. And say OK. Okay. Next, click on that same face and create a sketch and make a rectangle like so. Go to Project Geometry and select this top line. Click on Vertical Constraint, find the midpoint, and the midpoint, lock it in place, and then dimension it. It has a width of 0.5, and there's no depth that we need to add because we're just going to be cutting out. We are going to extrude this entire rectangle into the part 0.625. Next, we're going to add a hole, a simple hole on this face using this circle as our concentric circle. This hole is going to have a depth of 0.776 and a diameter of 1.17. So it's going to be a large hole, and hit OK. Rotate it so you can see what it looks like. And if you look from the left side, you can see that that hole and that slot that we cut out meet. The last thing you need to add is a hole here. So go to Hole, click on this face, change all of this info. It's going to be a simple hole with a counter bore. Our counter bore diameter is 0.562 with a depth of 0.375. It goes through the entire part and has a bottom diameter of 0.39. We need to make sure that this is properly located. So click this bottom line, 0.5, click this side line, 0.5, and hit enter. We need to change the material of this to 4310 or 4320 to steel alloy. Save this as number 13, column.